Hello students, welcome to the class of sound and wave. We will continue our discussion with the plane progressive harmonic wave. We have discussed earlier the equation of plane progressive harmonic wave is given by y is equals to a sine omega t minus kx. This is the equation that we have discussed in the previous class, and we have also considered that y is the function of x comma t. What does it mean? If we change the position, then also y changes. What is y? Y is the displacement of particle. Y is the displacement of particle. And if the time is changing, then also the y is changing. So if you have, as you have observed, that here the particle is performing simple harmonic motion and the motion is being transferred, so it at different time the displacement is different. This is the displacement and the maximum value of displacement is a, and with position also you see that the displacement is changing. Here I have considered that the particle is starting from mean position, but we have mentioned the example also in the previous class that it is not always essential that the particle starts its discussion from mean position. So it is not essential that the particle will always start its discussion, its displacement from mean position. Suppose that here in this case the particle has started its displacement in this way. Naturally, some initial phase needs to be added. So we can write also y is equals to a sine omega t minus kx plus phi naught. This phi naught is your initial phase due to this one that we have seen in the earlier examples that I have mentioned. So here y is the particle displacement and the maximum value is a, that is amplitude. Now, what I would like to tell you, in this equation, in this function, which is y is the function of x comma t, there are two graphs hidden into this equation. In this equation, you understand that if I freeze the x, that means x is made constant, then y is equals to a sine omega t, and this is your what we have freeze the x. So this is what, this is basically your videography. That means you are concentrating on a single particle motion. Time is changing and you are concentrating on a single particle motion. So this is one graph that we are taking and it is basically your videography. We are concentrating our discussion on one particle. So one particle motion is analyzed. So here what? Y is the, what we have fixed? We have fixed x is fixed. That means constant. Similarly, if I fix the t, then you see y is equals to a sine minus kx t we have fixed, and if we are fixing the t, then we are getting this equation, and this equation is basically the photograph. Why it is a photograph? It is photograph in the sense that it is the curve between y and x. At a particular time, it is the curve between y and x, and when it is the curve between y and x, that represents the photograph. A particular, it is giving you the different particle position, the different value of y at a fixed time. That means it is the photograph. So I can say that it is basically photograph, and it is giving you the wave shape. It is telling about the wave shape. So here we are getting all particles at a fixed time, and here we are getting single particle motion. single particle, time is changing, y is changing, single particle is doing the simple harmonic motion, and that we are observing. And here in this case what we have observed? We have observed that the time is fixed, and at a particular time we have taken the snapshot, we have taken the photograph, and it is giving you for different x the position of y, the y it is representing. So this is basically your photograph and this is basically your videography. So what I mean to say that in the single equation we are getting two values. This is first value and this is second value. It is giving you the shape, all the particles at a fixed time, shape of the wave, and it is giving you a single particle position at different time interval. So this is the basic analysis of your y is equals to a sin omega t minus kx. So we have understood that y is equals to a sin omega t when x is fixed and y is equals to a sin minus kx when t is fixed. So two graph, this is the graph between y and x. This is basically your photograph, and this is basically your videography. Now I am trying to show you the graph, which type of graph we can expect in this relation. So here you see, first I am giving you this y and x, so it is minus a sin theta, so we will be getting y and x graph. Here x is there, here y is there, and this is the equation of your, this is the graph of your y and x, this is basically your photograph. And if you want to see this one, you will be getting, it is sine curve t. Here you see, this is yt curve, this is yx curve. So yx curve in this case is in this way, and yt curve in this case is in this way. Now what next I would like to tell you, suppose I am changing the equation. This was your equation. Now here I am taking y is equals to a sin kx minus omega t. Take it as equation number 2. So here if we will take the y is equals to a sin kx and y is equals to now you see, t is fixed, x is fixed. One equation is this and one equation is this. Now which type of graph is possible? If I take yx curve for this relation, you will be getting it is a simple sine curve, yx curve, simple sine curve. And if we take this one yt curve, it is in this way because it is minus sine theta type curve. So this gives you the basic internal hidden concept of the wave equation. Which wave equation? Y is equals to a sin omega t minus kx, and as the sign of t and k is opposite, so what we are observing that this is moving towards the positive x direction. If here it is plus, it is moving towards the negative x direction. So this is the equation of the wave moving along positive x direction. This is also the equation of wave moving along positive x direction, because here the two terms are different sign. Now we are trying to explain, I am trying to explain a very important aspect, that is your particle velocity. Y is equals to A sine omega t minus kx is the standard equation of wave. Now, if I find delta y by delta t, why delta y by delta t? Basically, I am x fixed. When I am fixing the x, that means I am taking the partial differentiation delta y by delta t. It is basically, what is delta y by delta t? Rate of change of displacement with respect to time, that is the velocity. And this is whose displacement? This is the displacement of particle. This is the displacement of particle. So if it is the displacement of particle, then it is giving you the particle velocity. It is giving you the particle velocity. So what we can get? We can get x we have fixed. So it is cos omega t minus kx, and omega t is omega. So it is giving you this is your particle velocity. If I want to find delta y by delta x, that means then what is delta y by delta x? T we have fixed. T we have fixed, that means it is giving you the slope of curve. Y and x curve slope is here. So it is giving you the slope of curve. Slope of a curve. So what we will get? We will get so we are getting, see, differentiation delta y by delta x, a cos omega t minus kx and kx ko minus k. So what we are getting? We are getting minus ak cos omega t minus kx. So this is your slope. If I divide equation 1 by 2, one divided by 2 gives what it gives. See it carefully. A omega by k minus cos will cancel. So we are getting minus omega by k. And what is this? I have discussed with you that k is equals to omega by v. So this tells v is equals to omega by k. What is this v? This is also representing v and this is also representing v. What this v is? This v is wave velocity. And what is this? This is basically particle velocity. So a very important result we are getting. What we are getting, and what is this? This is your slope. So what result we are getting? We are getting a result. Particle velocity Vp is equals to minus V wave into slope. Slope of what? Yx curve. Slope of Yx curve. So this is the important result that you are supposed to remember all the time. It is very, very important. See it carefully. Particle velocity is negative of wave velocity multiplied by slope. See it carefully. Particle velocity is negative of wave velocity and slope. Now let us try to analyze what is the use of relation particle velocity is negative of wave velocity and slope. Suppose here is a wave that is moving in positive x direction, and here is a particle 1, 2, and suppose here is 3. 1, 2, 3. Now my main problem is to make you understand, one particle is going up or down, two particle is going up or down, three particle is going up or down, it is going, that we have to find. In order to find that one, this is your wave velocity. So wave velocity is in positive x direction, it is in this direction, so it is your positive. If it will be in this direction, it will be taken as negative. So this is your wave velocity. Now, if we want to concentrate on particle velocity number 1, then you see, we have to find the slope. Y-x curve is there, you see. Here, theta 1. Theta 1 is less than 90. What does it mean? It means tan theta 1 is positive. And what is tan theta 1? Tan theta 1 is slope. So, slope is positive. Now, use this equation for particle 1. For particle 1, use this equation. For particle 1, use this equation. Wave velocity is positive. Slope is also positive. This is positive, this is positive. So what is the result? Particle velocity Vp is negative. And negative means what? In downward direction. This is positive, this is negative. So this particle is going in downward direction. This is the way confirmly you can say that the particle is going up or particle is going down. Now come to this particle. Now come to the particle number 2. If we come to the particle number 2, which is at highest position, so here you see, here the tangent is horizontal. So this was the analysis for particle 1. Now I am talking about for particle 2. For particle 2. And you can extend the relation to any of the particle. Now you see, for particle 2, wave velocity is positive, slope is 0. So if you will result the particle velocity by this relation, what you will get? Particle velocity is 0. That means this is at rest. Particle velocity is 0. That means it is at rest. It is temporarily at rest. Now if we talk about the third particle, for particle 3, you see, here I am taking the slope, this value you see, theta 3. Now you see, for particle 3, what we observe? Theta 3 is greater than 90. So tan theta 3 is negative. So slope is negative. Slope is negative. Slope is negative. This is positive. So result is negative, negative, positive. So Vp is equals to positive, and positive gives the direction that it is moving in this direction, upward. So for any particle you can analyze, or you can tell that whether the particle is going up or down, because in the wave on a string, when the wave is moving on a string, you should be capable in saying which particle is going up and which particle is going down, because this can be a very important aspect of the question that is being asked frequently in the entrance examination. So basic concept of wave, by basic hidden concept of wave, you can analyze this relation also. And I have told you one more method, that you have to shift the wave. Now the same wave I am generating here, and let us analyze that whether it is contradictory or not if I use the same method, the method that I have told you. See here, what I have told you, this is your same I am taking. By common sense, you have to apply this method, that in the wave direction you will have to proceed. You will have to proceed in wave direction. If we talk about the particle 1, you see it is coming down. Particle 3, here it is going up, and this is at rest. So by this analogy also you can say all the particle here will come down and all the particle here will go up, and this will come down. So by this analogy also you can say, just shift the wave in the direction of wave motion, and you can understand that which particle is going up and which particle is going down. This hidden concept of wave will certainly empower you and will make you capable in a better understanding of wave. So this thing should be clearly understood by you people. Suppose one example I am giving you, that is of this nature. Just by looking at the diagram, you should be able in understanding that 1, 2 and 3 particles are at rest. They are at rest. Wave is going in this direction. This is the wave direction. And if we talk about here the slope is maximum. Here the slope is maximum. So 4, 5 and 6 will have maximum Four, 5, 6 will have maximum velocity, because here the slope is maximum. So you should be able in analyzing by seeing the graph that which type of motion is there and in what way. If we reverse the direction of wave, then also you should be able in giving the answer that which particle is going up, which particle is going down. So that should be clearly understood by you people. Now I want to talk with you the differential equation of wave. want to talk with you the differential equation of wave. In simple harmonic motion, you have seen that A is equals to minus omega square x. A is equals to minus omega square x. That means d2x by dt2 plus omega square x is equals to 0. This is basically your differential form of SHM. It is the differential form of SHM. And the similar pattern I would like to discuss with you on the differential form of wave. What is the differential form of wave that I would like to discuss with you? Just now we have discussed y is equals to a sine omega t minus kx. Wave is going in positive x direction. And delta y by delta t, this is giving you a omega cos omega t minus kx. This is particle velocity. Now if I want a different, here what we have fixed, here we have fixed the x. If we further differentiate it, that means particle acceleration, it will give delta 2y by delta t2 is equals to minus a omega square sine omega t minus kx. Differentiation. Cos sine and omega t, omega, so omega square, cos minus sine, so here minus. So it is your, take it as equation number 1. If we want to find delta y by delta x, now you see delta y by delta x, this is your acceleration but this is slope. Delta y by delta x minus a k cos omega t minus k. It is giving you the differentiation. A sine cos omega t minus kx and minus kx is minus k, so minus a. So delta 2y delta x square is equals to minus a k square sine. See, minus minus plus cos minus, so 3 minus are there, so ultimately 1 minus will be there, and k square. Take it as equation number 2. So if we divide this by this, we are trying to divide this by this, what we are getting? So 1 divided by 2 gives see here, a will cancel, negative will cancel, sine will cancel, it is omega square by k square. And what is omega square by k square? Omega square by k square is your, omega by k is your v, so this is your v square. And what is v square? V is your wave velocity. V is your wave velocity, omega by k. So what we are getting? We are getting delta 2y by delta t square is equals to v square delta 2y by delta x square. This is the differential form of wave. This one is the differential equation of wave. Any equation, any function y which is function of x comma t, any function which is of this nature, if satisfies this equation, this is called differential equation of wave. You should be able to understanding, sometimes in entrance examination this is directly being asked, and in our regular examination also it is being asked that find the differential equation of wave. So this is the differential equation of wave. This is the difference, and what is this? This is your wave velocity. Now you see, this was the differential equation of SHM, and this is the differential equation of wave. So you should understand this thing very carefully, and many times we have to any wave. Now the question arises in our syllabus, mainly it is your plane progressive simple harmonic wave. Harmonic wave. We have to discuss harmonic wave. In harmonic wave, it is the sine and cosine function is there. But is it essential that always the source particle is doing simple harmonic motion? If the source particle is doing simple harmonic motion, then we can expect a simple harmonic motion, a simple harmonic wave. But it is essential that always the source particle will be doing simple harmonic motion. It can do any type of wave. It can do any type of motion. So, but if it is wave, it will definitely satisfy this relation. And if it is doing simple, if the source particle, if I am doing in this way, the wave generator is in this way. If I am doing in this way, the wave generator is in this way. So, the shape of wave depends upon the type of motion given to the source. If the source is performing simple harmonic motion, then we can say that it is a simple harmonic wave. But it can do any type of motion. For example, you can take, I am giving this motion, I am dividing in this way. This, like that only. So then the shape of wave will change. If I am doing in this way, the shape of wave will change. If I am doing in this way, so many types of waves are possible. Triangular wave is there, a square wave is there, like that only different types of waves are possible. But in our syllabus, it is simple harmonic wave. But any equation, but any function of x comma t, if satisfies this relation, that represents the wave. This thing should be clearly understood to you people, and you should remember also the differential equation of wave. Now I will give one or two examples to make you understand that how we can use this differential equation of wave. The differential equation of wave has a solution y is equals to f(ax) plus bt. This type of solution is there. This differential equation of wave. This type of solution is there. So by looking at the solution only, you can say, looking at the wave equation, you can say that this will satisfy this equation or not. If the solution is of this type solution, of, you will see that this will have the solution, this type solution of differential equation. For example, I have discussed y is equals to a sine omega t minus kx. When I am discussing y is equals to a sine omega t minus kx, this is also ax plus bt type solution. This is also ax plus bt type solution, but sine is there, so it is harmonic wave and it is a wave. So it is this type of solution is there, so it is wave. First question, it is wave. You can say one more important aspect about this, that wave velocity, or better you say speed, wave speed in this relation is coefficient of t by coefficient of x, magnitude. Coefficient of t by coefficient of x. So this will give you the magnitude of speed. You can tell the direction of wave also. If in the solution A is positive and B is negative. One is positive, one is negative. That means wave is moving in positive x direction. If in the solution A is negative and B is positive, then also it is moving in positive x direction. That means if the sign of A and B are different, then they are moving in positive x direction. On the other hand, if A is negative and B is also negative, it is moving in negative x direction. Or A is positive and B is also positive, then also it is moving in negative x direction. Now you see what I mean to say here, that here coefficient of x and coefficient of t has opposite sign, so this is moving in positive x direction. If I take the example y is equals to a sine omega t plus kx. If I take the example y is equals to a sine omega t plus kx, then you see, you will observe here the coefficient of t and coefficient of x are positive, both are positive. That means it is moving in negative x direction. If we take y is equals to a sine kx minus omega t, you might have understood that coefficient of t and coefficient of x are of opposite sign, so it will be giving you the positive x direction. Also, I have told you that coefficient of t and coefficient of x represents velocity. So here magnitude, if you will take omega by k is equals to v. Not in this, but in every situation where you will be getting this type of relation, here the velocity will be your b by a. Magnitude and direction you can see by this one. So both magnitude and direction you will be able in getting by this relation. I will try to make you understand this by giving the example. Let us take an example first. Y is equals to 4 by x minus 2t whole square plus 2. Does it represent wave? The question arises, does it represent the wave? Now, in the differential form of equation, I have told you that y should be the function of ax plus bt, and here it is of this form, ax plus bt. Here a is equals to plus 1 and b is equals to minus 2. So first thing is there that it represents wave. So it is representing your wave because the solution is, this is of the type ax plus bt. This is this type ax plus bt type. So it is representing the wave. Then the second question is there, what is wave velocity? If you want to find the wave velocity, what I have said? I have said wave velocity v wave is equals to coefficient of t magnitude by coefficient of x magnitude. So coefficient of t magnitude is how much? 2 by 1, and it is in centimeter, so 2 centimeter per second. Now the third thing is there, direction. Direction. What is the direction? As you observe here, the coefficient of t and x has, one is positive and one is negative. So it is moving in. So first answer is this. This is your first answer. This is your second answer. And third answer is direction. Direction is towards, direction as it is opposite. So direction is towards positive x direction. It is moving towards positive x direction. Why? Coefficient of t and coefficient of b has opposite sign, as I told you. Second example we are taking, y is equals to e to the power minus x plus 2t. Does it represent wave? Now the solution is of type y is equals to f ax plus bt. So it will certainly satisfy this equation, and so this represents wave. Wave is there. It is representing wave. You can do this thing also. I will show you, by doing this also you will be getting the wave. And if you talk about the wave velocity, velocity of wave, that must be equals to coefficient of t by coefficient of x magnitude. So you are getting it as, if it is centimeter second, centimeter second. So if you are telling the coefficient of t should be 2 by 1, that means 2 unit of velocity, whatever we shall be using, this will represent the velocity. This will represent the velocity. If I want to tell this thing, I want to prove this relation by this one, that whether it is wave or not. Here by this relation we have discussed that it is representing wave, and here by this relation I want to say. So let us try to solve this by this relation, whether it is wave or not. So see, del y by del t, if I differentiate 2 e to the power minus x plus 2t, if I take del 2y by del t2, we will get 4 e to the power minus x plus 2t. Differentiation you should know carefully, that how I have differentiated. E to the power x differentiation is e to the power x. So this we are getting. Now del y by del x, you see, del y by del x is minus e to the power minus x plus 2t, and del 2y by del x2, this should be e to the power minus x plus 2t, minus minus plus. So what I mean to say here, here you see, so del 2y, by this relation what we are getting, del 2y by del t2, here you see, is equals to 4 times, and what is this, del 2y by del x2, see here. And what is this representing? This is representing v square. So v square is equals to 4, that is v is equals to 2. Same relation we are getting, and as the sign is different, so it is moving in positive x direction. Moving in positive x direction. So you have understood that this any function which satisfies this relation, this I have proved by both relation, by this also and by this also, this differential equation. So by this relation we can understand in any way that this can be understood that this is the wave. Generally this type of question usually needs the deep level concept for solving, and that is the part of your syllabus. So I have gone into this deeper section for understanding of the wave, particularly the differential form of wave. Otherwise sometime in the medical and engineering entrance 1 directly this equation is being asked, or if it, but you should be capable in solving any type of question if it is being asked in this format. With this much discussion of plane progressive harmonic wave concept, I hope that it will make you capable and powerful enough to solve any question on plane progressive harmonic wave. Though at the end of the chapter we will be doing some more questions, some more elaborative questions on the plane progressive harmonic wave, but this much amount of discussion is sufficient enough for you people for answering the questions that can be asked in any examination of your level. In the next section, I will try to discuss with you the stationary wave. Right now I was talking about the progressive wave and wave in general. In the next lecture I will try to discuss with you the stationary wave concept and calculation, and then we will end this chapter with the problem based on the concept of wave. Thank you. Have a nice day.